This one we cannot. Well, we can sort of do it, but so cosecant, I'm going to snip this in, but cosecant is the reciprocal of cosine. I'm sorry, of sine. I misspoke there. So sine is going to be the reciprocal of that number. So do you see how letters A and B are the right reciprocals?
I do not see your screen.
No, I'm just talking. Go ahead and go ahead and share your screen one more time. I was trying to get you to see that you want to get it down to two answers. And I'm asking you to look at answers A and B, and I'm going to share my screen, but do you see that A and B say sine equals 18 over 19, which is the reciprocal of your given problem, cosecant?
Yeah.
Okay, you have to at a minimum be able to do that. I mean, that's the only way that you're going to be able to get through this on your own. So that what I'm trying to remind you of is that cosecant is really 1 over sine. So if this is cosecant, then sine is the reciprocal of it, which is 18 over 19, which is why these two are the possibilities here.
Okay.
Okay. Now the reason you do that is because if you look at, like, say any of the other ones, you just got to find one of set of values of these. Like, you either got to find cosine because cosine is different in both. You got to find tangent because they're different in both, and so on. So sine is opposite over hypotenuse. So that's 18 over 19. And so this third side you find from the Pythagorean theorem. So I've got a squared plus 18 squared equals 19 squared. You definitely want to use your calculators for this. You're going to find, though, that a squared equals 37 and a equals the square root of 37. But you can manipulate this equation. It's 19 squared minus 18 squared to get a squared. So that's the square root of 37 there. So now you have to decide, and theta is always down here, always in this lower left. Which one do you want to do? And let's just do cosine of theta. Cosine of theta is adjacent over hypotenuse. The adjacent is the square root of 37, and the hypotenuse is 19. And again, like, you're comparing these two answers to match yours.
Right.
So the one that matches is this one here. So therefore it is answer A. I would definitely recommend trying to work through this on your own at some point. You don't want to try guessing. It matters a lot to get through this, but it's up to you. So whenever you're ready, if you want to go ahead and share your screen again, we can look at the next question together.
Okay.
Dance. Can you dance? Next, dance. There you go.
Okay, could you just scroll down and see if there's any more of these right triangle problems like we just did? Because it looks like I mean, I'm wondering if these are all mixed up or if they are in a particular order.
I want to say it goes from like section to section.
Okay.
So after that one, no, there should not be.
Okay. So yeah. So maybe you get a break there. If you want to go back to your first problem there, their second problem, maybe you get a small break there with only getting one of those on a test or quiz. A question 2, please. Okay. So let me snip this in. When we worked through these problems previously, I mentioned that you should immediately be able to find the third angle of the right triangle, because the third angle and the given angle, they have to add up to 90. So if you can, while I'm working here, I would get your scientific calculator side by side with your screen. But this is 90 minus 19, which is 71 degrees. So that gets us down to those 3 answers. Is that
And
okay?
then how did you get 90, or is a right triangle always 90?
Well, this one's 90 here. And so the idea is that the three angles in a right triangle, let's call them F plus D plus E, they equal 180. But since F is always 90, or one of the angles is always 90 when you subtract 90, the other two angles have to equal 90. So this one that's not the right angle and this other one that's not the right angle, they have to add up to 90. And that's how you quickly figure out, oh yeah, it's 71 degrees. Now, when you get three answers like this, what I notice right away is that the D is different in each of them. And that's the next thing to calculate. We want to calculate side D there.
Mm-hmm.
Okay, so this is 19 degrees up here. We want to find side D, and you have options here. You have sine, TOA, and TOA here, cosine and tangent. So relative to 19, what is D and what is 12? And your options are O, A, or H. Like is D adjacent? Is it the hypotenuse? Is it opposite? Same with 12. Is it adjacent, opposite, or is it hypotenuse?
Hypotenuse.
The hypotenuse is always the longest side. It's the one that's across from the 90.
Not adjacent.
So adjacent means next to. So you might think, oh, well, the hypotenuse is next to. The adjacent is a leg. It's always a leg. So I guess maybe this isn't clear, but O and A are always legs. And A is the one that's right next to it. I mean, if your friend is adjacent to you, they're right next to you. If someone's sitting across from you on the table, you would say that's opposite. So the one to use here is tangent. Tangent of 19 degrees equals the opposite over the adjacent. And you want to solve for D. So to do that, you multiply both sides by 12 to clear the 12. And this part I'm going to put in, just highlight it this time. This part that I'm highlighting here, you want to put in your Desmos Scientific. And that should be one of these three numbers here. Now make sure your mode is in degrees. We may be moving back and forth between radian and degree in this section, so make sure it's all good.
Okay. Anyone in is it 4.13?
Sounds right. Sounds right. Yep. Is your mode in degrees?
Yes.
Okay. Yeah. I mean, that's very reasonable.
Okay. So that brings us down to, oh, would it just be A?
Yes.
Or would it be A and E? A or D?
Well, we already crossed out D because of the angle. So we're down to, and the reason is that you do that first because it's fast and you get rid of one of the answers.
Oh, okay. Oh, okay. Now I get it. All right.
All right, so this one's really similar. It's the same problem with different numbers. Which answer can we immediately eliminate? Or in other words, what is the missing angle that you can quickly find?
The adjacent one.
The missing angle is a number. It's the angle that is in the lower right. This angle right here, we can find that really quickly. It's 90 minus 39.
Okay. Oh, okay, yeah, right. And that would be 61.
Are you using the Desmos Scientific? You really should have it up to what the calculations.
Yeah, 51.
51. So notice that this answer is gone. C is gone. Okay. Now, when you look at the three answers for D, you see an overlap here. So you don't want to use that one, but in E, there is not an overlap. So we want to find E. So I'm going to just redraw it here. 39 degrees, E and 22. So again, O and A, they're legs. So is E an O or is it an A? Is it opposite or is it adjacent to this angle?
Adjacent.
It is adjacent. Yeah, it's next to. The 22 is the hypotenuse. Okay, so you want the trig function. So katoa, you want the trig function that uses the adjacent and the hypotenuse. Which of these three is it? Sine uses opposite and hypotenuse. Cosine is adjacent and hypotenuse. Tangent is opposite and
Cosine.
cosine. So the cosine of 39 equals E over 22. You clear the E by multiplying both sides by the 22. So E equals 22 cosine 39.
I got 17.10.
So it looks like that's answer A.
Okay. And then I did this one on my own. I think it's right, but I'm just gonna have you.
Yeah, go ahead and share your screen and I'll look at it with you.
Okay.
263. So this is the one that's going, yeah, that direction. And it's just, yeah, good. That looks good. Okay, so coterminal. Go ahead and make that Desmos Scientific kind of side by side with your screen here. Well, the next few we can do using that. You want to drag that to the middle right position. Good. All right. So the coterminal angle comes from adding or subtracting 360. So I would first try adding it. I would go 153 plus 360. And see if that number is there. And it is. Now, if it wasn't there, then you would have to add 360 again or subtract 360 more than once until you get the number that's there. All right, so number six there, if you want to scroll down a little bit. Okay, so see how all the answers have a pi in them? When you're using the Desmos Scientific, you'd never want to put pi in unless you're rounding or something like that. This one you're not. So go ahead and type the angle measure in that box over there on the right for the 153 plus 3. Yeah, type in 35. Okay, so now to convert from degrees to radians, you want to multiply by pi over 180, but you don't want to put the pi in. So it's, instead of pi, you just put 1. So times 1 divided by 180. Okay. Now, none of those appear. You've got to hit that fraction button over there on the right, and it'll convert it to a fraction for you.
Okay.
Now, what are you going to do to remember that? Because I didn't write anything down. I just talked you through it. How are you going to remember that tomorrow?
I wrote down just add 360 to the number until you get the answer.
But you might also subtract 360, and that's for the previous problem. What about for this one?
Keep subtracting or adding until I get the number.
Yes, I mean, that's true for question 5, but not for question 6. And that's what I'm asking about. Like for question 6, how are you going to remember?
To convert to radians, I will know to multiply by 1 and divide by 180.
Okay. And there's a pi though. There's always a pi in there. That's important. Okay.
Right.
Okay, question 7, if you want to scroll down. I wrote a few notes in here also, in case you want to look at them later. Okay, so you're converting from radian to degrees. So this time you do want the pi. So notice like it's an exception. So this one you literally want to put in the minus pi over 30 in your calculator there. Okay, so now to go to degrees, you multiply, and it's 180 divided by pi.
Oh, okay. And would I multiply by 30?
Nope, you gotta keep the number in there to start. Nope, you gotta put the minus pi over 30 in. You gotta start with that. And then you're going to multiply in parentheses by 180 divided by pi. Okay, and this one works out nicely because the pi's cancel.
Right. Okay.
All right, so I'm going to grab, I'm going to grab this snip here and I'll talk you through it. Or, no, I'm not talking, I'll work it out here. So let me share my screen. All right, so that says let 20, 48 be a point on the terminal side of an angle. So what you would want to visualize is, where is 20, 48? Well, it's over here in the first quadrant somewhere. You see that? And in the first quadrant, again, not to scale, but 20 is your X and 48 is your Y. And theta is always this angle right here. I've drawn a bunch of triangles where theta is always in that position. Okay, so we normally do sine, cosine first and then tangent. But because they give you the opposite and the adjacent, we're going to do tangent first. So tangent is opposite over adjacent, 48 over 20. Now in your problem, I believe it's simplified. Like this doesn't appear in any of the answers. Can you confirm that? So if that's the case, go to your Desmos scientific calculator over there on the right, type in 48 over 20 and let it reduce it for you. Figure out the fraction that it is without having to do the calculations. You should see this right here.
It's 2.4 or 12 over 5.
Yes. Now what you want to do is go look for the answers where tangent is 12 over 5 and see how many you can get it down to.
Wait, how do I do that?
I'm asking you to look at the answers and figure out which one says tangent equals 12 over 5.
Oh, my bad. I thought you said multiply it. I was like, wait, what? It'd be either B or C.
Okay, so now the next thing we can do is remember that cotangent is the flip of this. Does that help at all? Does that get you down to one of the answers?
No.
Okay, so unfortunately, that means you have to find the third side C. So the third side C is found from A squared plus B squared equals C squared. So that's 20 squared plus 48 squared equals C squared. And then you take a square root. So what you can do with your Desmos Scientific is put the square root symbol, 20 squared plus 48 squared here, and you do get a nice number this time.
Okay. 52.
52, right? Okay, so now you said it was down to B, answers B and C, right?
Yeah.
Okay, so when you look at B and C, which is different? Is it sine? Is it cosine? Which should we do, sine or cosine, to figure out which one is different?
Sine.
Okay, so the sine of this angle is the opposite over the hypotenuse. So that's 48 over 52. And you should reduce that.
12 over 13.
12 over 13, yeah. And does that get you down to the right answer?
Yes, it should be B.
Okay.
All right. Now on to the next one.
All right, so here we're gonna kind of like do it indirectly. So notice it wants you to figure out the sine of minus 450, the cosine of minus 450.
Mm-hmm.
So go to your Desmos calculator there
Mm-hmm.
and do a cosine of minus 450. Probably want to put all that in parentheses there, yeah. Okay, so that actually gets you down to, well, we did cosine, so that's what that gets you down to first or the second, right?
Yeah.
Right. So notice between A and B, tangent is 0 in A and it's undefined in B. So tangent would be the next one that I would have you try.
And I just put
You just put,
tangent.
yep, tangent instead of cosine.
Okay. Yep. So that one. Okay. That's pretty easy to do.
Okay, so this one is the same. Maybe this time do sine of 3 pi. And you want to change your mode to radian this time.
0. 0, 0, 0. -1. 0, 0. So it's either down to B or D.
Okay, so when you look at B and D, which one is different? Is
Oh, never mind. I found it. It's D.
found it? Okay.
Oh wait. No, because 0 is undefined when it's opposite, right?
Which one did you try first? Did you try sine of 3 pi?
Yeah, I did sine, and then I went to cosine, and then I did tangent.
Okay.
And
So if you're not sure, you can always restart and get it down to the ones that you think it is. So sine of 3 pi is 0. That gets you down to B or D. But notice cosine is the same in both, so you wouldn't want to try that. Tangent is the same in both. You wouldn't want to try that. So what is different in both? Cosecant. Do you see that? See how cosecant is both? CSC is different in both? It's undefined in B and it's 0 there. So I think that's what you're asking. Cosecant is the reciprocal of sine. So what is the reciprocal of 0?
undefined.
Undefined. Yeah, so you got it.
Yeah. Okay.
All right. So 11's tough here because you got to know where 329 is.
In the chart.
Yeah. Do you have that?
Yeah, I do.
Okay. So if you've got that handy, you'll notice, and I'll share my screen here. It's 329. Yeah. So the angle here is 329. It's kind of right there. And the reference angle is always the angle. It's the smallest angle to get back to the x-axis. So in your problem here, it's this amount right here. So you've already gone what did I say was 320? 329?
Yeah.
So how much more to get to 360? You just subtract the two numbers. Like how much further? You're driving somewhere, it's 360 miles, you've gone 329. How much further do you have to go?
34.
Use the calculator. There's no reason to guess here. You got technology at your disposal.
31.
Yes. But it's not always 360 minus that. It truly depends on which quadrant you're in. So I can give you all the rules, but they're not. There's like 12 of them, and then there's radian and degree.
Right. Okay. Okay.
So maybe it's the same as. Maybe it'll just be slightly different number on the exam. Yeah. Whenever you're ready, go ahead and share your screen. So we'll take a look at the next one. I am not. There it is. Okay. This one I would just use a calculator for, even though it says not to, because you have a calculator available. Make sure your mode is in degrees.
Would I subtract this one by 360 also?
No, the calculator can handle that.
Oh. So, and then what?
Okay. So the next one is in radian, and you can tell that because it doesn't have a degree symbol. Yeah, I would do a parentheses. I don't know if it'll take that because you push the I did. You had a little space in there. Good.
Oh yeah, and then I did this one right here.
That looks right.
I'll pull up the other one. And then I didn't get. I think the rest is just green.
Yeah, we can do a quick graphing on that one. This one, grab the graphing calculator. Yeah, there you go. You got it. Maybe exit the page. You got a lot going. It's like the same page a couple of times.
Okay.
The X has to go inside parentheses. All right, so one of the things you can do is change your window. And I think that would really help here if you don't have the right graph. I'm not sure if you were able to or not.
Do what?
Did you select a graph yet on the left, or are you comparing it for like stretching and compressing?
No, I haven't selected anything yet.
Okay, you don't need to don't graph that next one yet. Just you can leave it blank. So go over to the right where the wrench is. And your x-axis, change it from 0 to 7 pi. 0 for the x. 0 before the x, to the left of the x. And then 7 pi to the right. You can type in pi for pi. All right, very good. And you can just click off somewhere. That's probably enough to get it. So like I think, and I don't see the fourth graph. To me, it looks a lot like graph 1.
Yeah, I was just supposed to graph one.
Yeah.
About there. Yep.
Then does it ask for anything else? Nope, it does not. All right, so I would. So do the same thing here for this one. So this time I would change your click on that wrench and change it from 0 to pi. And the way I'm choosing that right value is it's the whatever the rightmost value is on those graphs. You want to go from 0 to pi. I think you use the character O, not a number there.
Oh.
On the left there, make that. Okay, go back to the wrench. The left number has to be the smaller number. 0 is smaller than pi. So it has to be 0 on the left. It's almost always gonna be 0 for you. And then pi in that position, there it is. Okay. Now you just click off somewhere and you say, well, which one looks like my graph?
I'll go with that one.
The one that you clicked, it goes down once, but it comes up, then it goes down again. Okay, you can't change your window. So let's change the y-axis now as well. So go back to that wrench and change your x-axis from 0 to pi again. You gotta frame it in the right window. The x, not the y. We're gonna change the y, but go back to the x there. Yeah, change that to 0 to pi. You grabbed O again. Yeah, there it is. Okay, and this time, and here's how I'm choosing it. I'm looking at the numbers on the vertical scale. It's -4 to 4 on the y-axis. I'm looking at the on the left there where you can see down on the vertical axis goes down to -4 all the way up to +4.
Okay. So it'd be -4 and 4?
Yes. And the reason is you want your graph, your window to look just like theirs. You can't move it. That's the problem. Every time you move it, now you got to redo it or it's going to look different. It's not the first one.
Okay.
You got to go from 0 to pi, and now you got to. I mean, it's close. It'll probably be okay.
Okay.
So I actually so I'm gonna go back. I think the answer actually is A, even though it isn't the right graph, because it's got all the other stuff. It's the vertical stretch,
Okay.
but it's not the right graph.
Yeah.
So I would choose the first graph there. Although, wait,
Okay.
I see the issue. It's because it's not graph. We're graphing from 0 to pi. It should be going out to 3 pi, but they didn't put that character in. All right, I see. So if you were to change your wrench to 3 pi, you will see exactly that graph. Yeah, that will do it. Yes, now it looks very good.
It would be that one.
Nope, it's that first one.
Okay. Cool.
Same thing here. You just want to graph it and see. The +3 has to be outside the parentheses. It's implied. So you may have to change your window 0 to, well, it's 3 pi again. That's okay.
And you get to 1. I mean A.
Okay.
So I didn't need to change it?
You probably could change it from like -3 on your y-axis to on your y. Change that back to 0. Okay, and on the y-axis, go -3 to 7.
A,
Probably A if you want to scroll down. I think that's probably it. Yeah, that looks good.
yeah. Cool.
Same thing for 18.
Excuse me.
Yeah, there you go. Got it. +5 there. So this time you might want to change your window first because you're not sure where you're looking at it. With that wrench again. So maybe go from like -3 pi to 3 pi on the x, -3 pi. Okay, and then on the y, maybe go from 0 to 8. Okay, and see which one kind of looks like it. They actually go up a little higher than 8, but you probably see that, probably get a pretty good match from that. Yep, that looks good.
Right. Oh, yay.
Well done.
-2. That's good.
Okay, well, is there anything else you'd like us to look at today?
Awesome. And then No, I do not. This is like the end of chapter 9. I think next we're gonna be either doing maybe like another chapter, or if not, we're gonna be reviewing for the exam.
Sounds
So,
good.
yeah.
All right. Well, thanks so much for scheduling. I'll send you the notes here shortly, and I'll see you next time. You're welcome. Have a great day. Bye now.
All right, awesome. Thank you so much.